Good day to you all. You are welcome to Linear Equations College class, and the topic that we have here is homogeneous linear equations with constant coefficients. So any equation of this form is referred to as homogeneous linear equation. So homogeneous linear equation with constant coefficients is of this particular form, where p naught, p1 up to pn, they are the constant coefficient, they are the coefficients. And here we have f of d equals to this, the second equation that we have here, so we'll call it the characteristic equation. And all this m1, m2 up to mn, they are referred to as the characteristic root. m1, m2 up to mn, they are referred to as the characteristic root. And the first question that we have here is solve the square y over dx square plus the y dx minus 6y equals to 0. So here we're given a differential equation. So a differential equation, we have this, and to solve this, the first thing I need to do is we'll take this to the operator form. So we'll take this particular one to the operator form, and in the operator form, it is of the form that's d square minus d minus 6, and outside there we're going to have y equals to 0. So this is the d operator form, and we can actually take this to this particular form, which is a characteristic equation. So that will become m square minus m minus 6 equals to 0. So we can divide both sides by y, so that we can remove this particular y that is over there, and we can actually solve this using any form of this is a quadratic equation. We can actually solve this using factorization method or the quadratic formula, completing the square method, and so on. So now here we want to make use of, we can actually factorize this. So we can make use of factorization method. So here where we have the sum, which is the one at the middle, which is minus m, and also we have the product. Our product here, that's m squared times minus 6, which is minus 6 times m squared. That will be minus 6m squared. And the next thing I need to do here is we'll find the factors of 6. We have plus or minus 1, plus or minus 2, plus or minus 3, and also we have plus or minus 6 itself. So now we'll find two numbers, so that if we multiply, we'll get minus 6m squared, and when we add these two numbers together, the two factors, that will give us minus m. That will be minus 3m plus 2m. So if you multiply these two numbers together, minus 3m and plus 2m, when we multiply the two, when we find the product, that will give us minus 6m squared, and when we find the sum, that will give us minus m. So that will take us back to this particular equation that we have here, this particular quadratic equation. Instead of writing minus m, we'll replace that with minus 3m plus m. So this equation will now become m squared minus m minus 6 equals to, okay, so instead of writing minus m, we'll replace it with minus 3m plus 2m minus 6 equals 0. So from here, m is common, so I need to have m into m minus 3, plus here 2 is common here, so I need to have m minus 3 equals to 0. So by the time we multiply this bracket, it will give us m squared minus 3m. By the time we use plus 2 to multiply this, it will give us plus 2m minus 6. So, and what we have inside the two brackets must be the same thing. So the two brackets must be the same. So from here we can write m plus 2, then we'll pick one of the two brackets since they are the same, equals to 0. So from here it means m plus 2 equals to 0, or m minus 3 equals to 0. So from here we have m equals to minus 2, or we have m equals to 3. So here we can say this one is m1, while this one is m2. And when we check the two, this m1 and m2, they are referred to as the characteristic root. These are the root, m1 and m2. So these are the root of this particular differential equation under homogeneous linear equation with constant coefficients. So now, since m1 and m2 are not the same, the primitive that we're going to use in this case will be very much different. So that will be y equals to c1 exponential m1x plus, here we're going to have c2 exponential m2x. So this will be the primitive for this particular case. And since we have two roots, so that means we're going to have two constants, two essential arbitrary constants, that is c1 and c2. Then here we have the first root, which is m1, then the second one, which is m2. So now the next step will now be making use of the primitive. So y equals to, here we're going to have c1 exponential, the value of m1 is, that's minus 2, then we are putting x at the back, then we'll go to plus, this one will be c2, then here we have exponential 3x. So that is the primitive. Since we have the differential equation, then this is the primitive. Kindly like this video, comment and follow for more. Thank you.